Hey guys, we're finally back for another test drive. Sorry it's been a while. This test drive is a little bit special. This is a LT4 8-speed JK. I know a lot of you guys are interested in this combination, and I can tell you it's pretty awesome. I've been driving it now for a couple of days, and really what stands out is just how mild this engine is. Now, it has its other side, but here I am driving home in traffic, and there's no problem. And I have to think back to those days back in the 80s when I was driving a SS454 Chevelle, an LS6, and I had about 500 horsepower. It was a cammed engine, and I really couldn't go down the street without setting alarms off. Or I had my 427 Corvette. It was pushing 500 horsepower. But really, this engine is putting out closer to 700 horsepower, yet it's right at home in everyday traffic. And I'm going to predict that it's going to do pretty good off-road. We're going to be hitting the mountain with it. But just driving it around, you really don't notice much of a difference between this engine and an LT1. And an LT1 is very well behaved. The throttle response is good. There is no rubber band effect like some superchargers have, especially the V6s. The throttle is very linear. The whine from the blower is a little bit more than I would have expected, because I'm used to the LS9s and the LSAs, but this blower is putting out more than those blowers. So you definitely notice a little bit of whine when you get into it. Now, when you're just cruising along like I am now, you don't really hear it. You only hear it when you accelerate. I'm not sure if you can hear that on the camera. But the bottom line is this engine is very streetable. I would say it's going to equal any of the other LTs out there for drivability, but the horsepower is just tremendous. Now, the horsepower in the LT has to be thought of differently than the horsepower in, say, a Hemi or an LS. While the LT has a lot of horsepower, I think it's more about the torque in these engines, having the direct injection and the high compression. And yeah, this engine's 10-to-1 compression. That's massive for an engine that's supercharged. Now, this is a Roots style supercharger, I'm going to say. It's got the TVS blower on it versus a centrifugal. A lot of you guys know what the centrifugal supercharger is. I used to work with Paxton superchargers back in the day. They're more of a high RPM supercharger, different kind of whine, different kind of power delivery. This is more of a good old Roots style blower. So the drivability rivals that of a stock engine. As you can see here, even just crawling in this traffic, this engine is perfectly at home. I have really good throttle modulation. It's linear. There is no rubber band effect. In fact, the torque is instant. There is no waiting around for a turbocharger to spool up. It really does seem like an amazing package. You're idling at what, just over 500 RPM, 550 RPM, with an engine that has 700 horsepower. Now, we do have full functionality in this. This is an early JK, but we have cruise control. If I bring this back, you can see that we have Tapshift, so I can select my maximum gear. We have air conditioning, which I'm not gonna turn on because it's pretty cold outside, but everything works. We have got a intercooler pump on this. It's controlled by the computer, and we have been monitoring the intake air temps, and it's keeping it cool. We have wastegate control that is controlled by the computer to keep the engine safe. That's something that's really important in these modern engines. These engines are monitored for safety. In the old days, we put nitrous in an engine, or we put a blower on an engine. I've had wastegates stick. You're either going to damage the engine or something bad's going to happen. I remember when I was working with Chris Jacobs over at Jacobs Electronics, and we developed some of the nitrous safety stuff. We would see guys just pouring nitrous into their engines, which is really liquid oxygen, and after the fuel burn, you'd burn everything else, valves, pistons, and there really was not a lot to stop you from doing that. There's going to be a lot of debate what the best engine is out there. I've always been a GM guy, even though myself, I own Hemis, and one of my favorite muscle cars is my 70 Challenger TA 346 pack. But when it comes to engines, you really can't beat the small block Chevy, big block Chevy, LS, LT. I really love these engines. I'm lucky to know a couple of these engineers that have worked on these modern muscle car engines, and One guy I know in particular actually worked on both the Hellcat and the LT4, LT5, and his take on it is, when it comes to pump gas, these GM motors are probably king of the hill. While the Chrysler motors are capable of putting out more horsepower, it's under more perfect conditions, running higher grade fuel, ambient temperature being right. So really, I don't think at the end of the day it matters which one's more powerful. They're both extremely powerful, and I'm driving along in this JK with 40s, and I have to restrain my right foot because just touching the throttle, it takes off like a Z06 Corvette. So this is where 40 years of muscle car technology has got us. We've gone from the rump cammed engines and the early blowers, the 671s and the early centrifugal blowers, a lot of them adapted from World War II aircraft, to something that's really been refined. And what you get with a factory calibration, meaning this engine was designed from the ground up to be supercharged. Now technically supercharging could mean turbocharging or supercharging. This is a TVS style blower, and when you combine that with a GM multi-bar operating system, and that's really important. The reason it's important is when you take an engine that's designed to run on one bar, that's one atmosphere of pressure, which is about 14.7 psi, and you try to put a blower on it, when it transitions from normally aspirated to boost or going under pressure, the operating system really has a problem dealing with that. Yes, you can fool the map sensor, add map sensors, and do different things. But when you get an engine that's designed from the ground up for a blower, so the compression ratio, you have pressure sensors before and after the blower, intake temp sensors before and after the blower, you have all this technology that's monitoring this blower. The end result is an engine that basically runs like any other engine, any other normally aspirated V8 engine, but it has that extra horsepower. And here's another observation. I've driven some really heavy JKs with blowers, and I remember some of the earlier LS blown engines that we did. And I did notice that at the higher speeds, like going up to Utah, going up some of the grades, the blower would kick in with just a couple of pounds of boost. And I was getting better economy than a normally aspirated engine that would downshift, maybe go into performance enrichment. What I noticed is the blown engine would stay in closed loop, so the oxygen sensors were still switching. We're still running 14.2 to 14.5 air-fuel ratio, so I was actually getting better economy with a blown engine. Now this vehicle is a perfect example of that because this customer lives up in Colorado. Actually, I don't think he lives in Colorado, he vacations in Colorado, but that's where the vehicle is based. So when he gets up there to 10,000 feet. Now, I don't really think 6,000 feet is that much of a problem. The basic rule of thumb is you lose about 3% performance for every 1,000 feet. So at 6,000 feet, you're losing about 18% of your power. But when you got an engine with 450 horsepower, that's probably not a whole lot. But at 10,000 feet, you're losing about 30% of your horsepower, and some of the grades and passes in Colorado and other states can exceed that. So he wanted something that would not lose that performance. And a lot of you know that turbochargers and superchargers were not only designed for performance, but for running at high altitudes. So you see dual stage turbo superchargers, and back in World War II, there was a lot of development work done on forced induction. It was top secret stuff at the time, like the P38, to get an engine to perform at high altitude, because there's really not a lot of air up there. If you talk about 25,000, 30,000 feet, the air is extremely thin. So we need to somehow force that oxygen into the engine. And turbocharging, supercharging, and turbo supercharging obviously were the solution. Now I'm talking about piston engines, whether it's a radial or an inline. The turbine engines are kind of a different deal. And by the end of World War II, when turbines came out, that was kind of the end of the piston-driven airplane engines, because they just couldn't compete with the turbines at high altitude. That's not to say that airplanes didn't continue with piston engines. We're still running Lycomings and Continentals that were designed 50, 60, 70 years ago in general aviation, because they work fine at lower altitude. I remember flying some of the old Cessnas, like the 172s, and having to do circuits to try to get enough altitude to go over mountains going to Mammoth, where the guys with the turbocharged engines were just flying over those mountains. And it's kind of the same thing down here on the ground. If I take this heavy JK, which feels extremely powerful at 2,000 feet, which is about what we're at here in Vegas, and then I take this Jeep up to Colorado and I run it over the Eisenhower Pass, it's still going to be powerful, because we're now taking that 10-to-1 engine that's losing 30% of its horsepower, and we're using force induction to get that horsepower back. And I will say that is one of the concerns when I talk to guys and they call me up and they say, hey, what engine should I get? And I get a lot of calls from the guys in Colorado, obviously, because they're operating at high altitude with these little V6 engines, and these V6 engines that only have 200 horsepower, and you're losing 30% of that. It's pretty pathetic. So these guys want to maintain that horsepower up at high altitude. Now, low altitude, back in Los Angeles, I was lucky enough to grow up during the hot rod era, and we just used blowers for horsepower. We just wanted to get raw horsepower. Today, the trend is to go to smaller engines, put some kind of force induction on them. The Europeans have been doing that for a lot of years. The new JL has now done that with the Alfa Romeo engine, and it works. I still subscribe to the theory that there is no replacement for displacement. If we have a 6.2 liter engine that has multiple displacement, or an engine that can cut its cylinders off to mimic a small displacement engine, I prefer that, because I do believe that larger displacement engine is more efficient under a heavy load, especially in a heavy vehicle. You don't see 1 liter motors in semi-trucks, and there's a reason for that. So getting back to the use of a supercharger, of course you can put it on your vehicle to have bragging rights. There really is no downside to it. I'm driving this engine right now. It's as mild as can be. I would be completely happy driving this every day. So getting back to my previous thought, you can take a V8 engine and run all around the country, and even run some of the grades up in Utah, go to Moab, go to Rubicon, and because you get 400, 450 horsepower, you're fine. But you get into some of these grades, you're towing a trailer, you're at 8, 10, 12,000 feet. Then even the V8 engine starts to run a little bit flat. Well, the supercharger is going to get you that power back. So when these guys call me up and they say, hey, what engine do I want? First thing I ask them is, where do you live? If you live in Los Angeles or Florida, you're at sea level, you never hit a mountain, there is no reason to supercharge your vehicle, there is no reason to get a large displacement engine. But if you live at high altitude and you tow a trailer and you have a really heavy JKUR 1 tons, then things start to change. So this particular vehicle is going to high altitude, and it's going to keep basically the same performance as, let's say, an LS3 or a 6.4 Hemi up at those altitudes, just like if it were at sea level. I say there is no downside to this engine, but I guess there probably is. The cost of this engine is more than an LT1. I think the LT1 is an awesome engine, and I would have no reservation putting an LT1 in my Jeep. In fact, I probably wouldn't have any reservation putting a 5.3 L83 or L84 in my Jeep. I feel that we've brought the cost of this conversion in line for good value. An LT4 build is going to run you $39,000 and change. That is for a new crate LT4 engine, a new crate 8L90 transmission. It's going to have the intercooler system, heavy-duty drive shafts, heavy-duty cooling. Now, it's not going to include things like suspension. It's not going to include an Atlas, of course, all that's available to you. But if you consider the horsepower, I still think that's a pretty good value when you consider what else is out there. You're pushing near 700 horsepower with stock drivability. I'm going to predict that this vehicle is going to do great off-road, just from experience with other supercharged V8s that we've done in the past. And just driving it here in traffic, like I said, it's completely controllable. There is nothing rump. There is nothing that would indicate that this motor has the power that it has. I'm proud to have this LT4 on the road. I would venture to say that this is probably the first fully integrated JK LT4 out there. We're talking all the CAN bus systems are integrated so that we have all the normal functionalities that you guys are used to. Computer controlled air conditioning, ESP, cruise control, wastegate control, intercooler control, etc. And you got to remember that this engine is working in concert with direct injection, continuous variable valve timing, and a lot of other technologies to just make the end result a perfectly linear, smooth power delivery. With this LT4, you would be hard-pressed to tell it has a blower on it other than the horsepower and the whine. GM has built these engines with warranty in mind, so we're not only using forged components like forged crankshafts in these engines, but the oiling systems, we're running a 2-stage oil pump, so it has the oil pressure when it needs it, and then it backs it off for economy. And that's another thing I don't think you can overlook. When we were running these 500 horsepower fire-breathing V8s back in the day, we were getting 7, 8, 9 miles to the gallon. I don't know what this engine's going to get. I'll give you some feedback on that after I get some miles on it. But the gas gauge really isn't moving that fast. So I predict it's going to probably get in the teens. So what we got here is economy, performance, and emissions compliance, which could be important depending on where you're at. This is not like a bolt-on or an add-on. This is a fully integrated OE system. And as you guys know, we're using a factory harness. I do believe this harness is off a ZL1 Corvette. We're using factory computers. That includes the engine control module and the transmission control module. This vehicle is running the tune out of a CTSV Cadillac Supercharged LT4 vehicle. So it has all the same benefits of that vehicle. It has the protection modes. There's been no modifications done to this calibration. Now you could easily tune this engine and get as much horsepower as you want. When you got a supercharger or a turbocharger, it's really easy to dial it up and get whatever kind of power you want until you blow something up. But read the forums. There's guys out there getting just massive horsepower out of these things. Personally, I think we got more horsepower than we need right now. This vehicle is not squirrely at all. It's not hard to drive. You think, oh, I got 700 horsepower, it's going to be a handful. It's really not. Your wife could drive this thing to a store. Now, when you get into it, yeah, it's a little more hairy. This vehicle has a long wheelbase. It's a 4-door. The suspension's pretty solid, and I want to say something on that because a couple of previous LT builds, we've had some iffy control arms and some suspension systems with worn out joints and geometry that's wrong, and you start getting torque steering a 500-600 horsepower engine, and you're talking about changing lanes when you get into it or when you slam the brakes on, and that's just something that's not acceptable. Before you put this kind of horsepower into a chassis, make sure that that chassis is solid. We're running 1-ton axles in this. We got heavy-duty suspension components. This vehicle does not have a heavy-duty Atlas because it had a Atlas 2 previously, and the Atlas 2 in general will hold up as long as you don't drive it like a gorilla. If you're going to go out and try to do burnouts with 40s, which this engine obviously can do, you're going to start breaking stuff. You don't really need to run an Atlas 4 in a V8, in my opinion, unless you have a special need for it. The Atlas 4 with a high-low section would not make a good candidate for these supercharged engines. In fact, I don't think you need them on any of the V8 engines, and if you guys talk to Advanced Adapters, they'll probably tell you the same thing. So the Atlas 2 is probably sufficient for this build. I know this customer and I don't think he's going to break it. Advanced does offer the MoTech Atlas, which we put in a lot of builds. It's pre-configured for our swap. It has the proper vehicle speed sensor delete, the sight tube, the flanges, etc. You just call them up, talk to Steve Roberts, say I want a MoTech Atlas, tell them what you're working on, an LS, an LT, a 6L80, an 8L90, and they'll set it up for you. On the LT4 builds, we do spend a couple extra dollars, and Steve and the guys put in some heavy-duty parts. I'm not exactly sure what they are. I think it's pins and gears out of their race case. And it's just insurance against the power of this LT4. I've actually seen the axles on these supercharged builds fail before the Atlas. But I will say that I don't really see a lot of failures for guys that drive their Jeeps with some reason, like myself. I've got over 80,000 miles on my 6.2 JK with stock axles and not a single problem. We're going to hit the mountain tomorrow, and I will give you some more of my impressions on this engine and how it does off-road. So just as I suspected, this LT4 does fine running trails. We're near the top of the mountain. That's Las Vegas, way down there. As you can see, the Aeroforce gauge is indicating that we're in first gear. We're actually in park, but this is different than current gear. If I were to come back here into drive, we're obviously in first gear, but if I come back into the Tapshift mode, you'll notice it says 1. Now, going down this trail, if I'd like to, I can upshift into second, third, fourth. I think second gear is going to be good for going down this hill. So let's leave it there and let's take off. The blower really is not coming into play up here in the mountain. I don't really hear it. I think that under these light loads and low speeds, there's no reason to have the blower engaged. So I would say that this is really similar to a LT1 off-road. Now, I'm going to go down into first gear because we're in high range. As you know, we have a Atlas in this, and I tell you guys a lot. Let's go into first. So now we're in first, and yeah, it's holding me back just fine. In fact, I might even want to throttle it just to go down this hill. A lot of the guys that talk to me say, hey, I want a 5-to-1 transfer case or a 4.3. But the reality is, when you've got all this torque with an 11-to-1 compression engine, that would be for the standard LT, or this supercharged LT4 is 10-to-1. You have more firing pulses per revolution than the V6. You just have all this tremendous torque. You don't need to gear down like you used to. The little V6 has no displacement, or very little displacement compared to the V8. So your compression braking is not going to be the same. So here we are crawling on the mountain with a supercharged LT4 8-speed. And it's pretty amazing that we can run this thing down the highway at 80 miles an hour in comfort on the street, pushing close to 700 horsepower, and then get off road and crawl it like it's a stalker. That's pretty amazing. And I don't know what the fuel economy is going to be, but that needle's not moving too fast, so it's going to be comparable to some of the normally aspirated vehicles.